There we go. So we got the recorder going, and we'll double check also to make sure there's enough space. Yeah, pretty sure there's enough space. We got 12.4 gigabytes, so that's plenty. Okay, all right. Well, it's plenty only until I write an infinite loop that will keep dumping stuff into a file. Then it won't take very long to fill up 12 gigabytes. Okay. All right, so what we're going to do next is to assemble the program, which means just massive lookup to the opcodes and figure out the bit patterns and stuff like that. Okay,
is there like a sheet that has like all the syntax for assembly? That like LDI, so like JLJ.
So these are kind of made up of his own, right?
Well, these are all made up because we don't really have this processor.
Yeah.
So I'm just making these as we go. But I suppose we can do it over here. Okay, so we have no op, and then this one we can say CPR. Okay, so this is one way, which is using the C representation. So the other one is CPR, and then the one getting changed is always on the left-hand side to preserve the ordering as in the assignment operation. So this is copying Y to X. This one is JL to register X. This one is JO to register X. And this one is JS to register X. We got the LDIs. This is subtraction. So subtract Y from X. So subtract XY like that. This is a right shift. We store the result back into X. So we do it like this. This is the negation of X, just not. Oh, yep, okay. And then this one is JMPX. Okay, we'll just say that this is without the parentheses. And this one is JCX. This one is JZX. Okay, is that what you're looking for? This is compare XY, and we don't have any use of these particular opcodes, so I'll just kind of leave them alone. This one is store, so we are storing into Y or whatever Y points to from X. So is that okay? So now we have a full equivalent map of stuff. Okay, so let me see what is the best way to do it. I can do a dual screen thing. Would that be okay with you guys, or do you prefer to use one single screen? Because we do have two physical screens, but in order to use a dual screen, you guys will have to turn your head all the time, which may not be what you want to do. So I'm going to go with the other approach. Okay, so I'm going to go with the approach of just resizing. Okay, we want it like this. And where's my resize? Oh, there we go. So we'll do it like this. Okay, and then drag this one out so it becomes its own browser. There we go. Okay. So now we can now specify the actual offset. Okay. So 0, 0 is the location in RAM. This is the address in RAM. And then at this location in RAM, what do we want over there? So looking up to the left-hand side, we can now look up the actual instructions. So the LDI, or the A equals PC++ is different. This one here. This is definitely a 6C. And everything is in hexadecimal. I'm not going to use any base other than hexadecimal, so I'm not going to use 0x as a prefix because it's just going to be very repetitive. The next location is going to be int1. I don't know where int1 is at this point, so it's going to be to be fixed up. So I'm just going to use int1 instead of tbd int1 because all of those are tbds. So the next location is 02 because the first instruction takes up 2 bytes. The opcode is only using 1 byte, but it needs an extra byte to specify what value do we want to store into register A. Is that okay? So the next instruction is LDB0, which is the next one. And because over here, we can see that, B is a 6D, okay? So 6D, and then just a 0 to specify that we want to load it with a 0. This one is an LD instruction. The LD instruction is this guy here. We want to use A for both X and Y, which means it becomes a 70 as an opcode. This is at location 4, and this is a 70 as an opcode. Then we move on to location 05. We have an LDIC. So LDIC is going to be the next one up, which is a 6.2. Oops, not 6.2. I take it back. It's going to be a 6E. 6E, and then followed by L1, and L1 is also to be determined. That takes up 2 bytes. Are we doing okay so far with the assembling process? I'm just reading either the mnemonics, or we can also use the other notation, the pseudo C notation, and converting all of those based on this table here into the bit pattern. But I write it in hexadecimal just so that we don't have to use a lot of space in the document. Is that okay so far? Yep, go ahead.
So with your word processor, the RAM takes in hexadecimal locations anyways.
That is correct.
So
Yep.
it would make sense to write it that way.
Yep, it does. Okay, so then we have a compare. Okay, this one does not have the mnemonic specified yet. So we have a compare BA. And the compare operation is down here. So it starts with a, okay, compare starts with a E. So this one here. This is a location 07. We have a E, and depending on what we're comparing to, we have a B, which is a 0100, so it's an E4. Yep, okay, it's an E4. And then we have a conditional branch here. Conditional branch based on the L flag is specified up here. We have a 6, and then followed by, and the register that we use for branching to tell us where to branch to is register C, which is a 10, which is also a 2. So now we have location 08 being a 6. What did I say again? 6. Yep, 6.2, that's correct. Okay, there we go. And then this is location 09. We have a JZ. JZ is specified down here. This is JZ. It is a B, and then we have a 01 here. We have a 10, so it is a BB. Yep, it is a BB. Okay, let me double check. 1011 1011. So it's a BB. And then we get to here. We have a subtraction. Subtraction is with storing. It is right after the addition. It is this guy. It is a 9. This is at location 0A. The first nibble is a 9, and then the second nibble is 0100, which is a 4. And then we get back to this one, so we can just kind of copy that one. So at location 0B, we have 6C int 1. Okay, we can make this a little bit wider so we don't scroll around unnecessarily. There we go. So we have a ST, which is the last instruction. It is a F as the first. Oh, okay. This is 0D, and then we have ST. The first hexadecimal digit is an F because it's 1111, and then over here we got A is 00, Y is 01. So if we have a F1 here. Question? Okay. All right. So we are now pretty much done. Okay, we have a label definition L1 here. We'll deal with that later. And then we have the halt instruction. Yep.
So it says that your star A is your Y, which would be 0, and your B is X, which would be a 1. So it should be 0100, right?
This is using this particular pattern where X. Oh, you're right. Okay, because so XX is the other side. Okay, so we have Yeah, let me just double check. Yep. Okay, you're right. Okay, so we have a XX is a 0, 1, so we have a F4. Okay. Good job. And then we have a halt instruction here. The halt instruction is easy. It's just 0, 1. And the location is 0E. At location 0E, we have a 0, 1 instruction opcode for halt. And then at location 0F, it is reserved to represent the actual variable. And this is the one where we can say, well, we'll decide what to do with this one. Okay. So because we have to test the program, and this is how we're going to test it, is to initialize it to a different value, positive and negative, and see whether the program gets the job done or not. Okay. So now that we have the program quote-unquote assembled, we can now go back and fix up all the labels. So L1 is what? What is the address of L1? 0E, very good. Okay, so all the references to L1 is just going to be replaced by a 0E. And instead of just overwriting it, I'm just going to say 0E, and then in parentheses L1, just to remind ourselves what is at 0E. It is the label L1. And then int1 is down here as 0F. So this is going to be a 0F, which in symbolic name is int1. And then this one is also 0F, in parentheses int1. So now we have the entire program assembled and ready to be entered into RAM. Are we doing okay so far? Is that okay? All right. Okay, so when we're done with this process, we go back to the command line because I never really generate all the instructions that we need. So this is a good time to test this, okay? So we say cat empty.rom, which is basically just all zeros in ROM. And then we just have to pick out the instructions that we actually need in order to implement this program. So the instructions that we need in this case is no up. It's always needed because it is the instruction fetch cycle. We need compare. We need copy register. We need halt. We need JL. We don't need an unconditional branch, so we can leave it alone. We need LDI for sure. We also need ST and subtraction. I think those are the instructions that we need. Let me just double check here. Oh, we need JZ too. Yep. Okay, so we also need JZ. And that's about it. It's good to put all the J's, at the end because they reuse some of the code for some of the useless opcodes. So I'm going to put JL over here instead of earlier, like that. There we go. Okay, so I'm going to generate all of this code and put it up to the folder ahead, one level up, as opcodes.rom. And it says command not found because I haven't really made all yet. Okay. Oh, I know why. Because okay, this is a silly thing. Because in Linux, if your command is in the same folder, you have to specify /. It's not in the system path. That's why. Okay, you just have to do / everything. Now, obviously, it would be kind of fun to make the name of a command /. So when people ask you, so what is the name of the command? It's /. And then what? It's just /. Or if it's in the same folder as when you want to run it, it becomes // This is actually why the domain name /. Came about. Do you guys go to /. as a website? /.org. So when people ask you what is the URL to that website, you go http:///.org, right? So which part is is actually the name of the URL, and which part is actually a punctuation becomes a little bit blurred, let's just say. Okay, so there we go. This time it works. We'll just do a little quick visual check to make sure that the ROM file has the commands. Okay. Yeah, looks right to me. Okay, but this is what it looks like. Okay, so when you have all the commands, or at least all the commands that we need in this case implemented, all the opcodes, it kind of looks like this. Okay, there will be a lot of 14 times 0 because those are basically spacing out instructions or opcodes of the same family. Okay, all right. So we got this. It's time to fire up Logisim and write the code in RAM. Load the opcodes into ROM and run the program. Okay, so we'll go ahead and do that. So we say java.jar downloads logsim, and the circuit file is in the parent folder. Okay, there we go. Okay, so before we do anything else, let's click the reset button because we don't want to load the program into RAM and then click the reset button. And then we go to the ROM module and say edit content, open. And since I created the new opcodes.rom over here, this is the file that I want to select. Do the open and just make sure that it looks correct to me. Okay, and we should have instructions all the way up to F's because the F commands are the store commands. Okay, so it looks okay to me. Close window. And now we specify what goes into RAM. Yep, question? Nope, okay. I thought there was a question. So now we go back here and specify the content in RAM. The entire processor is reset already, so we want to make sure that we don't click the reset button again because when you click the reset button, everything in RAM is going to be erased. Okay, so we don't want to click the reset button unnecessarily. And we just have to, okay, so the question now is, how do I do this without having to flip-flop all day long between the screens? Okay, let's see. Okay, just one more time, this guy, maybe it's scrolled over like that. And let's see if I can just type it. I guess I have to select it first. And edit content. One more. There we go. Okay, so I think we can do this. So we have a 6C, 0F, 6D, 00, 70. Now, when I'm doing this, I'm also double checking that the location is correct because occasionally I count locations incorrectly. So I have to double check to make sure that we are in fact at location 05 at this point. Okay, so we have a 6E, 0E, E4, 62, BB, 94. So it's the 94 at an A. Yep, looks that way. So we're good. So we 6C, 0F, F4, 01 as the hold instruction, and this is the last byte, which we use as our int1 as the variable. Okay, is that okay so far?
Yeah.
Okay, so I don't want to have to re-enter this program just in case I implemented the opcodes incorrectly and this program doesn't work. I don't want to have to re-enter this. So I'm going to save this program. Okay, and I'll save this program as absolute value.ram. Okay. The extension is entirely up to you. There's no enforcement of any kind of standard, so you can use any extension you want. Okay, so now we have this program, and it's time to actually execute the program and find out what it does. Okay. What do you want to use as the variable, as the value that we are taking the absolute value of? 0, 0 is not very exciting because it doesn't really, it's not supposed to do anything, okay? So we want to use a negative value.
Negative 10.
Okay, what is negative 10? Quick.
A. Absolute value of 10.
Yes, but what is negative 10? What is the 8-bit representation of negative 10 as a signed number?
I can't do this so fast. I have to use a piece of paper.
Is it EE?
No, it's not EE. It's F something. I know it's within the F because FF is -1.
Oh.
So just go backwards, right? FE is -2, and so on. So FF is -1, and that's 15, right? So 15 minus 9
So that would be
is
that'd be
6.
6. That's right.
I think it's F6.
6.
Okay, well, we can double check. Okay, we
F6?
take the 2's complement of F6 and see whether we get 10
Oh,
back.
because you need the F to
Okay.
represent the sign.
So we have 1, 1, 1, 1, and 6 is 0, 1, 1, 0, right? Okay, I'm probably wrong because
It should be
wait,
6.
it's probably right because we have to do a ones complement, which is 0, 0, 0, 0, 1, 0, 0, 1, and then do a +1.
There's always +1 no matter which direction you go in.
Exactly. You always do a 2's complement and then the +1. So now we have 1, 0, 1, 0 here. It is in fact a 10. So that's -10 as a 8-bit number represented as a hexadecimal number. Now say that again. Okay. So let me say that one more time because this is actually important. Okay, I'm not just playing with words. We are representing the value of -10. Okay, so -10 is a value. We are representing that value as a binary number. Okay, as a binary number, it is 1111, 0, 110. But when we enter that number into the editor, it has to be in hexadecimal. So F6 is the hexadecimal representation of the binary bit pattern that is representing -10 as a value. Is that okay? And every bit of that sentence is actually important because because it states why we are using what base and so on.
No, you said every bit.
Every bit, yes.
That's it.
No pun intended, yes. Yep.
So to get -10, we have to drop regular 10 number and make 2's complement.
Yes. That would be one quick way
So
to do
10,
it.
it will be 8 plus 2.
Right. But the other way to do it is to say 0, 0 is 0, 0, right? FF is -1, FE is -2, FD is -3, and just keep going. So that's also workable, but using 2's complement is the quickest way to do it. Is that okay? All right. Okay, so let's go ahead and do this. So here's the question. Do we feel brave enough that we just want to let it run, let the clock do it
Yes.
without actually?
It probably works.
Huh?
It probably works.
I'm not so sure. I'm not as confident as you guys are.
Let's see what happens. It's ready for production.
It's only if you're working for Comcast. Not Comcast, Qualcomm.
I suggest you save the RAM first so we can reload it.
Looks good to me. Let's release the product. We can always fix it later, right?
Hey, that's
Save it as.
Okay, so we'll go ahead and do it like this, okay? But I personally do not have a whole lot of confidence in this. So we'll clock it at maybe 2 hertz, 2 clocks per second, and enable it. Okay. Tick enabled. Okay. Now, the question is, if it does work correctly, okay, and I just leave the clock on its own and keep clicking, would it execute anything that is unintentional?
Maybe.
Mm-hmm. We ended the whole program with a 0, 1, which is a hold instruction. So it can clock all day long, it will still be stuck here. Okay? But we should see this location changing to a 0A, which is the hexadecimal representation of the binary bit pattern representing the value of 10. Okay. Okay, so let's go ahead, enable it. This gives me an idea of Christmas lights. Uh-oh.
After 0,
Uh-oh.
clock it higher.
It's stuck at a certain location. Okay, so, all right. This is great too because now I can talk about how to debug a design.
Oh man.
And do we have time for that? Oh, we got time. We have a whole hour to do this. Okay, so if the program is not working, what do? First thing, check the PC. Okay, the program counter is stuck at a 2. Okay, you can see that it's not changing. Okay, but the fact that it's getting stuck means that the microcode engine is also getting stuck. Okay, so we can look at the program, the microcode count. Okay, so we are at the location 0f, which is all zeros, which is the halt instruction. Okay, so the question is, how do we get here? This is a 0f, and the 0f is the second byte of the program, this one here. So that means 6C as an LDI instruction is not working the way it's supposed to. You had the same problem?
And then in the end, I must have made a mistake somewhere in my ROM file because I just re-input it and then it started working again.
Okay, so but basically I just diagnosed the program and found out that the microcode corresponding to LDI is not working. It is not incrementing the program counter correctly. Yep.
What instruction is supposed to be a 0f?
It's not supposed to be an instruction. 6C at location 0 is an instruction, it's an opcode, but the byte right after that is just the bit pattern to copy into register A. So 0f is supposed to be copied into register A, but by itself it is not supposed to be an opcode. Okay, so that's why. So this is how I diagnosed the problem. Go like, oh, okay, we have a problem, and the problem is because when I implemented the LDI instruction, the program counter is not auto-incrementing. Okay, well, that's not too bad. We can fix that problem. Okay, so the first thing we need to do is to check my spreadsheet because I think I got it wrong in the spreadsheet to begin with, because I did double check to make sure it does match this spreadsheet. So in the spreadsheet, PC++ basically means that, oh, maybe it's the next one? No. Okay, so let's take a look at the end here. Okay, so in the spreadsheet, it's supposed to be 1D80016. Let's check the ROM file and see if it is that. Okay, it is at 60 location. So we switch back to the ROM. And at the content, go to 6C0. 6C0. And it is incorrect. Okay, it's a 1C00380 as opposed to a 1D80016. So they're off by a lot. Holy smokes. Okay. But the other one seems to be correct. 1D80036. So these are 1357, and this is a 1 here. So this is correct, but for some reason this one is incorrect. So my code generator or my microcode generator did not work correctly, or so it seems. Okay. So the next thing we need to do is to debug that, okay, and see whether that it really is the source of the problem. Okay. So we go to opcodes, and we just want to pinpoint the problem of the LDI instruction. So that means I just need to do a cat mt.rom, pipe it to LDI, and just observe the result. Okay, once again, it's // There we go. And this one did give us the right result, which is 1D80016, which does match the spreadsheet. So somehow it became a 1C something, right?
Yeah, I had a problem with Logisim when I was typing in when I was doing one of the homework assignments. I put in a number that was I don't know, too big, and it changed my number.
Okay. Well, let's see if we can find that ROM location in here. Okay,
see
because
if you could manually type in the one number there and see if it will accept it or change it in Logisim. So that would.
okay, so in here it's also incorrect. It is a 1C00380, which is what we observed in here. So the ROM file got it wrong, and I'm suspecting one of my other instructions is using this location.
So would you grep for this, or?
I just
What instruction might you
well, I might have made a mistake in one of the in the file of one of the other instructions and reused the opcode 6C. Okay, that happens when you're working on your code at 12 a.m. and your daughter is having a anxiety attack because she cannot get her homework done, and the homework involves, guess what? One flew over the cuckoo's nest. That doesn't mix with programming very
How
well.
old is your daughter?
About 16. Aren't you going to offer your
My kids are young.
condolences?
Yeah. I'm still, I got a lot,
Okay.
so.
Well, we only have 6C in LDI, so none of the other opcode is supposed to override this. Okay, so the other thing we can also do is just to look at all the write slides from all the .c files and see if they look right or not. Okay. So I know it's the 6 series that is going to be a problem, and the JS can be a problem. Okay, so we want to double check JS is supposed to be 6.8. So double check that. JS.
Isn't 6C the last address of one of the instructions? So it wouldn't show up when you begin writing a slice, since it'd be the last one in the loop.
Say again?
If you go in the ROM,
Mhm.
you see the incorrect value at 6C is at the end of the previous slice. So it wouldn't show up as a value for right in the beginning of the slice.
You mean this one?
Yeah, like look at the one before it, C00280. So 6C0 is the end
Of this series.
yeah. So you look for the one that starts at 600.
6.0.
60, and that would be the incorrect one.
Okay. And that's going to be a JL. But there are other ones too. So JL is one, and then there's a 6.4 and 6.8.
But doesn't it only write up from that address?
Yes.
So it would only be the JL one.
But the one that is causing this problem, okay, so there's one instruction corresponding to 6.8, but it's not one single instruction because the 6.8 is parameterized using the XX. So I'm suspecting the offset to the XX is incorrect, and that's why it overwrote the wrong locations. Okay, so I have to look at all the J instructions because those are potentially the ones with the problem, especially the ones starting with 6. And I think we got it. I think we got it. It is this one. That's the problem because X does not have an offset of 2 bits. Okay, let's go back to the description here. The one corresponding to 6.0 is 0110 0000. Okay, so we have this one here, and the bit shift of X should be 0 instead of 2. That is the problem. So I got the bit position of the 2 bits to specify the register incorrect. So it's shifting by the wrong part, and that's why it overwrote the other locations. So the problem is with JL. Okay, so we'll fix JL and double check the other ones just to make sure that I don't have the same issue. The B's are correct. They are all with shifted by 2. The 6 are the ones that are incorrect. So JL is the only one that has this problem. Okay, so that's good to know. JL.c. We just need to send off. There we go. So we just have to change this to 0. Not to 0. I think next time I'll make it so that I have a parser that can parse 0110 00XX, and it can automatically find out where the bits are, how the bits are scattered. Then I won't make this I won't be making this mistake by hand anymore.
Instead you'll break the entire thing.
Huh?
Instead you'll break the entire thing if you mess up with the parser.
Which is better than just breaking one thing, because breaking the entire thing makes it very obvious that something is wrong. Okay, so make all and regenerate the file that we had earlier. Okay, maybe you're not using this command. Maybe using over here. Oops. Yep, there we go. And go back to the emulator. And I think we have to stop the emulator first before we can reload it. So go back to, yep, that's the emulator. Stop. And stop that. Just load the image again. Microcode this one. And double check at location 6C0. Okay.
Maybe that's how Intel updates the microcode.
Sorry?
Maybe that's how Intel updates the microcode.
I don't know how you can update the microcode of the Intel processor, but I know you can do it. Because when you start Linux, one of the messages that scrolls by really fast says something about loading microcode for the processor. Yeah. It scrolls by really fast, but it is there. Okay, so we got everything now, and the program in RAM is still here. Okay, so that's good. But I'm going to have to reset the program, so that means I'm going to lose the program in RAM, just have to load it back later. So reset. Oh, it doesn't change that. Because, oh, simulation has to be enabled to actually click it. There we go. So click. Everything is zeroed out, very good. Load image. This is the absolute value program. There we go. And enable. No. Okay.
Jump and never came back?
No, it has the same problem. I thought I did. Well, 6C0 now has the correct content, which is consistent with what I have in the spreadsheet, 1D80016. So if I go back to this spreadsheet, which is here, 1D80016 is correct. But the question is, is it updating the program counter? Okay. So PC enable is a 1, which means it is supposed to be updating the program counter. And PC mux is a 5. When PC mux specifies a 5, it's putting a 0 into PC mux. When we have a 0 in PC mux, it is going to do the increment like this. So the program counter should increment.
PC enable isn't on. PC enable isn't on.
It's not on anymore because now we are stuck in a in the other instruction, so that's why it's not on anymore.
What if we go by one click at a time?
Yep.
Take it at a time.
Yep. We probably have to do it that way. Okay. Oh, okay, that doesn't work. Have to stop the clicking, reset simulation, reload the RAM. There we go. And then we have to do it slow this time. Okay, Control T, Control T, Control T. Okay. So getting here. Okay, so this was to be correct. Okay, we get to 6C0. And we want to look at the pathways of the program counter over here. So at this point, the program counter is enabled to be updated. PC increment is a 1. And the input is a 2. So in the next clock cycle, the program counter should increment to a 2, but somehow it is not doing that. Okay, so Control T. There you go. It increments. And Control T, Control T.
Loading instruction.
Yep. It's loading instruction into the instruction register. That looks legitimate to me.
Good so far. That's what it's a 4.
Okay. And we want to look at the RAM location. Okay. It's going along. And this time it should do the conditional branch. Oh, okay, we are stepping in.
As soon as you look away, it breaks.
It's on the LDI, on the load immediate.
The last instruction we execute is the 7-0. And the 7-0 is not there because we do not have the instruction yet for that one. Yep, okay. So the 7-0 is corresponding to the LD instruction, so I forgot to put the LD instruction into the stream of instructions, or it is incorrectly put into it. So we'll figure out which one. The LD instruction was never put into there. Okay, well. But this is great. I mean, this is just going through the whole debug process. Okay, it's not a bug; it's a feature.
It's a feature we'll patch up later.
It's a feature of lecturing, because now I can actually show you guys how to debug. I mean, when was the last time you read a textbook where on the first page or the first few pages it will give you something that's not going to work, and then 10 pages later it will go like, well, that program is not supposed to work because it has these problems.
It wouldn't work, but it just wouldn't say that it didn't work.
Exactly.
It just give us bad code, but it never does that.
I personally think this is great. I mean, I just like this whole process of debugging. If you like debugging, having a bug in your program, it doesn't work, doesn't bother you, you're not self-judging and say, I'm so stupid, this program doesn't work, and you're not furious that the program is not working because when you scream at it, it doesn't work, you're probably an INTP person.
What about C++?
Yeah, right.
Sorry? Say again?
It depends on how close the deadline is.
Oh, yeah.
If it's due tomorrow and there's bugs, then I'm going to be pretty mad.
Yeah, if I don't have the next 2 hours to figure it out.
That also does not apply if you're writing C++.
I get pretty pissed.
Like it just gnaws at me.
It's funny though, if you walk away for like half an hour and do something else, in that half an hour, you might slightly be thinking about it. And then
Oh,
you
I forgot.
figure out how to fix it.
I forgot to reload it.
Sometimes it's
How many times have you said called it now?
I had to do it. Problem, like,
Load image, ROM. There we go. Double check. 700. Okay, we got stuff here. Okay.
I walked away for half an hour.
Go back here.
Sat near the fireplace.
Load image, absolute value. And let's put something back here. I think it was an F6. Okay, let's do it again. Oh. Uh-oh. Okay, so that's not good. And it went back. Why did it go
So
back
is that
there?
a conditional branch to
Oh, it had to grab the zero.
That wasn't supposed to
say period?
or it's a feature, right?
And
Did it go to location F6?
Yeah.
So it went to location F6 instead of changing the value over there.
so
And-
when did it do that?
Well,
take a walk.
take a walk. Okay, so we don't have the location F. Yeah,
Oh,
0F.
and that's 6C, should it be 0E, maybe?
6E, you mean this one? You mean this one?
No, I mean at location 0C.
At location 0C, which is this
That
one?
Yeah. Which instruction was that in our assembly code?
Let's check. Okay, that's not the one. This one here. It's supposed to be 6C because we are loading int1 into A, and then we're supposed to do a store, but we didn't get that far. We did not get that far at all.
Maybe the .byte 0 is actually 0E instead of 0F. If you look at the one at the bottom.
You mean this one?
No, the one under it.
This one?
Yeah.
This is the value of the variable that we are trying to find the absolute value of. So it should never become an opcode. But it did, okay? It did become an opcode, which means the value F6 is used in some kind of a jump instruction, which basically means, oh, maybe I forgot to change the, no, that was correct, okay? JC. We are doing a branch when it's not supposed to be doing a branch.
Maybe you're branching to.
Okay. Well, let's go ahead and do this again. Reset. Reload. And single step. Okay. Right. Well, the first instruction is working. The second instruction is working. And now it's the 7-0 instruction, which is the LD instruction. The LD instruction.
Let's check the registers.
Okay. Check the registers. We have 0F here.
So that thing is supposed to, right?
We're supposed to do the indirect, right? Because this is an LD instruction. We're supposed to go to location 0F, retrieve the content, which is F6, and then put it back into register A. Okay, Control T, Control T, Control T, and it is a 0, 0. Oh, okay.
Yeah.
Okay, so it is 0, 0, because in the RAM location we kept the 0, 0 as a default. Correct. Okay.
Yeah. Okay.
And it is back to, okay, there we go. So we're now moving on to 6E. And let me take a look. The 6E is corresponding to the LDI instruction to put something into register C.
So what do we have in register C now?
Yep, we should have an E, 0E in register C. So let's double check. Oops, that's the LU. Move back a little more. And that's correct. Okay, this is register C, so we got it correct. And then the E4. Okay, I'm gonna close. Okay, this is the right one. So the E4 is the compare instruction. So let's do the compare. Oops. Wrong window. Control T, Control T, Control T. And the compare instruction is the one that is not working. Okay. That's because there's no opcode corresponding to the compare instruction.
Do we need that one out too?
Yeah, no, I have that one here. So the question is it in the file first? Okay, if it's not in the file, then it's probably the command, the constant or the opcode in the compare instruction is not correct. So we'll take a look at this. That's hard to see. Let's see, we'll just run cat empty.rom, type it to CMP, and see what is going to be generated. Yep.
I found the problem with the compare. It starts at the wrong address. It goes at C0, which is for the what is that, AND instruction? And it should be E0. And then it works.
All right. So which one is the one with a C0? I probably do a copy paste and forget to modify. And? Yep. Okay. Just to double check and also have it recorded. Let's see here. So the compare is down here. It is supposed to be E0 and not a C0. Okay, so that explains that. Okay, very good. All right, so make all, okay, and then regenerate the ROM file. Go back to Logisim, reset simulation, reload it, Wrong file.
So when my programs don't work, it's really the processor to blame.
Sometimes.
You're gonna call Intel customer support. And
Does Intel have customer support?
I honestly don't know. I just made it up.
That'd be terrible.
Okay, so this one should skip all the way to 0, 1. Okay, it's just grabbing the content. And that's the compare. And here's the conditional branch. And one of the branches should happen is the JZ that should happen. This one should not happen, the next one should. And this one should go all the way to the 0, 1, which is up here because we are branching around the then branch. Yay! Finish line. Okay. Good. Okay, let's test, let's make sure that it does work the other way too. Control R, reset, reload the image. And this time we specify a F6 over here for -10. And then we clock it through. Oh, that's not good. Okay, so it went to location F6. It does store that correctly. Oh, because the address bus still latch out the content with that one single instruction. Okay. Okay, so it's not a big problem, but it is undesirable. Okay, so let's see if we can fix that. So let's do it one more time. Edit content, load. I know exactly why it's doing it. Okay. Okay. Okay, that's fine. This is not, okay? This is exactly F6. And when we look at the program counter, it is 05. So the instruction at 05 is the one that is causing the problem. And here we have the document. At 05, we have a 6C E0, 0E, which is a label. Let's check out the microcode. It's doing a 700, and the 700 is corresponding to the compare. So the compare instruction is incorrectly activating the address bus. Okay, let me just double check. The address bus is active, which means the RAM is being selected. And that is not right. Okay, that's not correct for the compare instruction. So that means in the compare instruction, I have to turn off the address bus or turn off the RAM altogether. There we go. Fix it. So the compare instruction is the one that is incorrect. And if I remember correctly, it is this flag that is controlling the. It's the fourth flag from the right end of the spreadsheet. So let's check that. This is not the right document. Here we go. Okay, so we're looking at the compare instruction. We'll store. Oh, I never really. Wait, it's not this one. It is this one. Row 20. No, that's RI mugs. So RAM select should be a 0. and RAM select is a 0. And when we look at the simulator, it's 1500016. When we go to the spreadsheet, oh, we don't have the actual code specified here. 19. Okay, 151D488. Oh, okay, that's not right. So 700 is not correct. That's a 7. Wait. No, 70 is this instruction. Where's the program counter? Program counter is 05, and 05 is here. But the opcode is trying to execute is 70. Location 05 is here. And in RAM, location 5 is a 70. This is location 4. This is location 5. Something is not right. Okay, let me check. See if I entered the program correctly. 60F600070. That is correct. So it looks like it skipped one instruction. Okay, let's double check everything. The program counter is a 05. The instruction register is a 70. But 05 is supposed to have an opcode of 6E and not a 70. Okay. Let's reset this. Load image. F6. There we go. First instruction. Second instruction. Now we get to 70, and at 70 we're supposed to load indirect A into A, and we want to check the register bank, and we should go to location 0F, grab whatever it has and put it into A. Control T, go to that location, grab the content, okay. So the issue is with this particular command. It's a LDAA. And then we have to compare these to the spreadsheet first. The LD is here. So 1016, that is correct. I think it's just a byproduct, because when we look at RAM, it's a read operation, which should not be interfering with the operation. And we're still executing the load instruction, so it's not done yet. And when we do Control T, we go back to the beginning. Okay, this is fine. Okay. Yep, it's going to do it correctly. I know exactly what is going on. There's no problem with the code. Okay, I know exactly what is going on here. It's the LD instruction, which is supposed to read a location in RAM and then put it back into a register. And guess what the register is currently used for? It drives the address bus. So the address bus gets instantly updated to the new value of register A. But we are not going to do anything about it anymore, because the clock cycle to update the register has already clocked. So it's a harmless change of the address bus. It doesn't really cause anything bad to happen, except in the simulator, it will still address the other location, but it's not going to do anything with the value of that location. So it's not a bug. It is just a side effect of how when you use a register to specify to store the result of an indirect, but it's the same register that you use to drive the address bus to begin with. This is what it is gonna look like. Is that okay? All right, so it's not a problem. It's just a side effect of the instruction of LD A with A itself.
So anytime you're using the same register
for dereferencing, then it will look like that it's going to the location at the wrong time. But since it's a read operation and the value of that location is no longer used to be stored in anything, so it's not going to do anything bad. It's just changing the location in RAM. Okay, so it does work. Are there any questions?
So when are you going to port Windows to it?
So all the exam is going to be is you're going to give us the processor design and ask us to implement one of these we haven't done, or something new?
Well, I think okay, first of all, it's not going to be a program this involved.
Okay.
So I'll give you maybe 2 or 3 instructions and ask you what it is going to do, what that's going to do.
Okay.
So I'll give you the opcode.
You'll give us the opcode.
I'll give you the opcode in binary, and then and I'll ask, okay, so what is the effect of executing these instructions? And you have to document, okay, this first instruction is going to change register A to blah blah blah. The second instruction is going to do this, and so on. So in other words, you're going to be the processor running the opcode. Okay, but you don't really have to run it like this using the actual logic sim, because once you understand the instruction or the meaning of the instructions, then you already know the actual side effect. Because I'm not going to ask you what's going to happen to the muxes or the demuxes, because those are all just utilities to help glue all the components together. So the questions will be specific to, okay, tell me about any changes to the registers. Tell me about changes to the flags, and so on and so forth. So there are specific things that we'll be asking and say, okay, if anything changes with these particular items, let me know. Is that okay?
You would also probably ask like program counter or instruction register, right?
Not necessarily, because those are all support features. The real features that are exposed to software are the registers, the flags, and to a certain extent, the program counter. So those are the things that we really care about because in software, those are all accessible to us. I can also ask a question that is kind of the reverse, which is, okay, this is what I want to do, not something as complicated as finding the length of a string, for instance. But I might ask you, okay, how do we, do some simple arithmetic operations, but it is not simple, but you need multiple instructions to do it, so you have to tell me the instructions to do it. In those cases, okay, I do not need you guys to assemble the program. You just need to give me the representation in either this kind of format or this kind of format. Take your pick. So give me some kind of code in mnemonics, and you do not have to assemble. Because the assembly process is really mechanical, that's really the most boring and the most mechanical step of writing programs in assembly language. So I would not want to. I don't like to do it myself, so I don't want you guys to have to do it in the exam.
Will you give us a list of the available instructions that we have?
They are pretty much listed here. Do you want a complete enumeration or?
Yeah, like during the test, do we have to bring it ourselves, or is it going to be provided?
I can provide it.
Okay.
Yeah. In other words, I will include a sheet that is close to this.
Yeah.
But cleaned up, and everything kind of formatted a little bit better. Okay.
Oh my god. The phone is brick.
And there might be one question that will ask you to implement the microcode of a new instruction. Okay, so we have all the basic instructions here, but I might ask you to implement something that is extra. When you implement a new instruction that is extra, what I probably will end up doing is just have you guys to fill in, not this one, or come on, to fill in an array like this. So you don't have to actually come up with the bit pattern. You just have to tell me what you want to specify for each field, but you don't have to come up with the actual number in the end. So that will help simplify your process a whole lot. Because it's all the bit shifting, all the bitwise OR that is taking up time, that is really kind of more difficult for people to do. But when it is just specifying what should go into RAM cell, RAM load, RI mux, and stuff like that, it's a little bit easier. Okay. Any questions? It is open book, open notes. Yep.
Yeah, question about ROM and all operators which supposed to be the ROM. So looks like you did some changes. So will you update all these changes for mnemonic commons? Some of your code was wrong just because you did some changes just because it was in wrong packaging, right?
My implementation of the microcode was incorrect in some of the files. Oh, so you want me to make sure that I upload the new file?
Yes.
Okay.
This first, and second, to get full like ROM or full commands.
Mm-hmm.
So how can I create this ROM?
To have all the instructions?
With all instructions.
Okay, so let me, one thing at a time. So what I'll do is I'm going to retar everything first. Okay, and make sure I re-upload that. So we'll get rid of this guy. And upload a new file. Okay, so there we go. So now it's updated, reflecting all the changes that I have made after debugging it. And then the second question is how we generate a file representing all the instructions.
Yes.
Okay. I don't know whether there's a quicker way to do this. Okay, but if you look at all the commands here, you basically just say cat empty ROM, and then you pipe it to either all of these. Okay, so you just say and /add pipe /and pipe /. So that's how we. So instead of just using the ones that I used, okay, before this I used this command, which is only missing like very few of the instructions. So if you finish this whole thing, I think I missed most of the ones missing are the conditional branch instructions. So I'm missing the unconditional branch. JC is missing. JZ is here. ZZ, JS is missing. JO is missing. What else am I missing? Subtract is here. Oh, OR is missing. AND is missing.
So there is no way how to do it here, like without naming each instruction.
That is correct. You have to name everything. But you can also make your own command to do this. So you put it into a script file. There may be a quicker way to do it. Let me think.
Right now.
Huh?
You can just make the script right now.
Yeah. Let me see.
So we're gonna execute everything with executable permissions in the current directory.
If you have extension for each of the files, some other letter like x.x.
Well, ROM to bin is not needed, so I'm going to remove that. Well, I'm looking at the extensions. The make file is the only one that has no extension, but it is a,
So you cannot select like.
I think I can do this. Let's see if this works.
Okay.
So we'll do an ls first, just to make sure whether this works or not. So we want to locate everything that starts with a lowercase, right? All the commands that we are interested in they all start with lowercase, but with no dot, no extension. So we don't want to. How do I specify no extension?
Not star. Like not star.
Well, let's see.
I would just specify
Does it
no extension.
Does it let you do negation?
Say again?
Does it let you do negation?
I think it does do negation, but you have to specify a.
Because you could add a filter and grab for the period and then negate that. Or no, that would work.
Okay, let's try this, because I think this is reg name. This is just regular expression, which is a lot easier to deal with. So it's just A to Z plus any number, at least one. Okay, regex.
You have to have
I'm just looking at the regular expression here. Okay, change the regular expression syntax understood by regex.
You could move everything to a different folder and then do ARM on anything that has a period.
Yeah, we could do that. Okay, sensitive versus case insensitive. There we go. Okay, so matches regular expression pattern, which is a pattern of the whole path, not a search. For example, to match a file name, blah blah blah, you can use the regular expression / or /. Okay. Understands by find a regular Emacs regular expression, but this can be changed by regular expression type. Okay. Okay, so what are the options here?
Yeah, you have to use exclamation point, like
Use the exclamation point.
What if you check for everything that has an executable permission?
Would that work? No.
What if you check for everything that has an executable permission?
So it's technically not working.
That will work.
Right.
And find can do that too.
Dude, this is the 4 stock ROM I downloaded.
And it won't work.
None of them.
That's executable.
They fail on Odin. Like,
Yeah, so just find out.
I just can't figure out what else is wrong.
I remember on
Dude, there's no Google thing.
There we go.
I Googled that error message and I
So that's good. Okay, so we can pipe this to.
I don't know
How wrong reason?
Yeah.
I had to find some stock.
I think it's just
I
gotta
had
push
the
it
same
back.
problems when I'm down.
Let's just make it a file.
I
Yeah.
found like some website. I don't even know how I found it.
I found some solution on the
I got
website.
someone online.
Find in Linux file without extension.
I just text my coworker,
okay.
this friend, like, dude, swap my phone out. Like,
Okay, so we say cat mt.rom,
and I need to work from home.
and then we just need a pipe for everything here.
Last weekend.
Yeah.
This would be kind of.
Can you replace every new line with a pipe instead, or does it not leave?
Say again?
Replace every new line with a pipe.
I don't know whether you can replace new lines. That's one of the things that's not as easy to specify.
So I'm pretty sure like 90% of the population voted for Hillary
Oh,
Clinton.
you can, indeed.
And then just get rid of the last one.
It's Tuesday, so like no one wanted to go out Friday. Like it's so sneaky. San Francisco. But like literally every single person I picked up was like just like a dog had just died, dude.
I was pre-delivery on Saturday.
And like
Everyone's all happy up there.
everyone,
Park over
everyone
there.
that talked, everyone that talked,
Republicans all over the place.
everyone that talked like all the time about like politics.
You could.
I was just like, so I was
Yeah.
trying to silence, you know, I was like, I don't know
Bin.
what's
There we go.
I'm gonna get very
There we go. Yep. So we got it. It's just not as clean as I want.
Chance, I can get you to sign that. or
Okay.
Fill it out. I guess there's a couple of things it needs from you.
Okay. All right. So we got the script file, but you can work on your own scripts too, if that's something that you want to work on. It's just a pipe involving all the individual commands. Alrighty. Well, thank you for your patience.
It's funny. In lecture, I was paying attention in lab.